Okay, the warm-up says simplify 4 square roots of 56. Whenever we first started learning about simplifying radicals, what did I always tell you should do first? Right, type it in the calculator to see if it's a perfect square. Well, when you type it in, what do you get? 29.9, right? And that's rounded, so I write approximately 29.9. Okay, but since it came out a decimal, that means it's not a perfect square. And so to simplify it in radical form, I'm going to need to factor tree. So what are the first factors of 56? 7 times 8. 7's prime, so it would just drop. 8 breaks down into a, okay, continue bringing down the prime numbers. And then 4 breaks down into 2 and 2. Now what do we do? Right. Right. The ones that were not circled were behaving, so they get to live inside the house, and they multiply together to make 14. The ones that were misbehaving, okay, well, hold on. Kill one, right, kick one out, and then multiply by the 4 that was already out there to make a final answer of, okay, and now what should we do? Type that one in. What is 8 square roots of 14 equal to? Approximately, because we rounded it, 29.9, which lets you know you've done it right. Do y'all remember how to do this? Because you will have to do it in May on the EOC, and you're probably going to have to do it in December on a midterm. Okay? Yeah, a midterm is a test that covers everything we've learned first semester. So this would be on the midterm, okay? All right, today we're going to be learning about properties of equality. And the first thing we're going to do is make a foldable. Now, I'm aware that some of your foldables are over there. He's recording the grades because I haven't had a chance to put them in the grade book yet. But you don't need them quite yet. First, we got to cut out some stuff anyway. Notebooks, and we're going to update the table of contents and essential question pages. Okay, today we're going to be learning about the properties of equality. Okay, we'll be gluing this down to page 40. So go ahead and update those 2 pages. Equality, that's where we are going to be gluing this down. So once you get it folded in half, you're going to glue it down to page 40. And you'll see where it says to glue it down, it says back side, and that's what you put the glue on. Okay, so we are going to be learning about these properties of equality. So I'm going to spread this out so that it'll kind of look like what it does when you open yours up. Okay, so the first property of equality we're going to talk about is called the reflexive property of equality. And that property says if A, then A equals A. Now, the easiest way that I can help you remember this property is Reflexive is kind of like the word reflection. And what is a reflection? Right, the same thing. Like when you look in the mirror, you see a reflection, right? And isn't it the same thing? Okay, it's a reflection. Well, look over here. A equals A. We have the equal sign, but don't you see the exact same thing on both sides? So it's like a reflection. So we're going to look in all your little papers to see which one represents this property. Krishad, which one? Right, if P, and so you're going to glue it down. I'm writing it, but you're going to glue that paper down. If P, then P equals P. Okay, do you see the other paper that represents this property? Right, the other one says if C, then C equals C. It's a reflection. You have the same thing on both sides. Okay, so that's what the reflexive property of equality says, is that you have the exact same thing on both sides. It's like a reflection in a mirror. They look identical on both sides of the equal sign. Yeah, you glue them both down into that top example box. Any questions so far? Everybody knows what we're doing? Okay, the next property of equality is called the symmetric property of equality. It says if A equals B, then B equals A. So you have the exact same things. It's just see how they flip-flop sides? You could write it this way, or you could just write it in reverse order and they're still equal. Now, the most common place that I see this happen in math, and some of you probably don't do it, but if you have OCD like I do, you always do it. Say that you've worked a whole long problem and you've done all your work and you end up with 2 equals x. How many of you at that point rewrite it as x equals 2? Anybody? A couple of people? A lot of people seem to like the variable on the left side. Okay, you can leave your answer like this and that's fine. But you could also reverse the order and put x on the left and 2 on the right, and that's fine. And that is the symmetric property of equality. It just says you can just take sides and flip-flop them, and they're still equal. Okay, so look through your little rectangles and see if you can find something that represents that property. Right? If Kn equals Br, then Br equals Kn is one of them. Did anybody find the second one? No, that's not the same property. Right. Right. Okay, I'm going to write them up here if you couldn't understand them. The first one that somebody said was if Kn equals Br, then Br equals Kn. All they did was take the Kn and move it to the right side and the Br and then moved it to the left side. It's still the same thing though. It's just a matter of preference. Okay, and then the other one was if Qn equals PR, oops, I wrote R. Then PR equals Qn. All right, the next property of equality is called the transitive property of equality. Okay, everybody kind of stop what you're doing and look at the board. Okay? Stop what you're doing, look at the board while I explain this one. All right, the transitive property of equality says if A equals B and B equals C, then A equals C. Okay, well let me try to help you understand that. See how A and C are both equal to B? Well, think about it. If A and C are both equal to B, wouldn't that mean they also equal each other? That's what the transitive property of equality says. So look through your remaining rectangles and see if you can find two cards that represent that property. Now that's one of them. Yep, that's the other one. Okay, if x equals 2 and y equals 2, then they equal each other. X equals y. Okay, so if x equals 2 and y equals 2, then x and y equal each other because they both equal 2. And then the other one people said was if a equals 5 and b equals 5, since they're obviously both equal to 5, then they both equal each other. A equals b. So go ahead and find those two and glue them down in that box. Okay, y'all got those glued down? All right, the next property is the addition property of equality. Everybody look at the board as I explain it, okay? Because if you're not looking and listening, then you're not going to get it. The addition property of equality says if A equals B, and then you take A and add C to it, and you take B and add C to it, they're still equal. Because if they were equal to begin with and you add the same thing on both sides, aren't they still going to be equal? Okay, this one's going to be a little harder to find. See in the remaining rectangles if you can find two cards where they have added the same number on both sides. You're not actually going to see the adding occur. You'll just have to know that they added on both sides. So I'll give you a minute to see if anybody can find it on their own, and then I'll tell you one of them if you can't. No. No. Okay, hold on. Madison's saying something. Yeah, she was starting. What did you say, Madison? Right. If 3x plus 13 equals 20, good job, Ty. If 3x plus 13 equals 20, right, that's the other one. Then 3x equals 7. And then the other one was if 2x plus 5 equals 12, I'm running out of room, then 2x equals 7. So glue those down, and then I'm just going to briefly talk about them a little bit more. That's why I just said glue them down. I'm going to talk about them more. Well, think about if you were working the problem 3x plus 13 equals 20. Okay, which property are we on? I think we just made a mistake. Hold on, I think we just made a mistake. Don't press them down. It's okay, they'll come up. The glue's not dry yet. Shh. Okay. Hold on, before we... Recording again. In this one, wouldn't you have to minus the 13 and it would cancel? And when you minus 13 from the 20, you'd get 7. And in this one, you would minus 5 and it would cancel. And when you minus the 5 from 12, it would be 7. That's subtraction property of equality. So now let's find the two that are addition, where you would have to add on both sides. Right. 6x minus 2 equals 10. So 6x equals 12, because wouldn't you have to add that 2 to both sides? And then what's the other one where you would have to add by the same number on both sides? Right. If 9x minus 8 equals 19, then 9x would equal 27, because what would you be adding on both sides? What would you be adding on both sides? The 8. Okay. So go ahead and get all those glued down in the right places, and then we'll move on to the multiplication property. Oh. It's 6x minus 2. It got mixed up with somebody around you. You need to see if somebody... you may have just found one on the floor from a previous period or something. Well, just wait. We'll see. Shh. Okay, turn around. Let's continue. Shh. Turn around. Close your mouths. Shh. Okay. Multiplication property of equality. Everybody look up here at the board while I explain it, please. Okay, the multiplication property of equality says if A equals B, and then you take A and multiply it by C, and you take B and multiply it by C, they're still equal. Because if they started out equal and you multiply them both by the same thing, are they still going to be equal? So, you don't have that many papers remaining. See if you can find the papers where if you were given that equation, you would have to multiply on both sides. Would you, if you were given the problem 8x equals 32, is the first thing you would do multiply on both sides? No. Okay, let me show y'all what I'm talking about. No, one of them looks like this. If x divided by 3 equals 2, then x equals 6. Because think about it, guys. If you were given the problem x divided by 3 equals 2, to solve for x, isn't the very first thing you would do is multiply by that 3 to get it out of the bottom? Right. And that means the other one is a divided by 2 equals 12. The first thing you would do on both sides is multiply by 2 on both sides, right? And a would equal 24. So when you're trying to figure out these properties, you need to look at the problem and say, well, if I were solving for x, what would I do on both sides? And if you would multiply on both sides, then it's the multiplication property of equality. Okay, now the division property. Find the two problems on the rectangles where the first thing you would have to do is divide on both sides. Yeah, you're right. No, Jessica's right. What'd you say? Right, look up at the board a second. If you were given that problem right there, isn't the very first thing you would do is divide by 7 on both sides? And when you divide by 7, wouldn't you end up with x equals 5? So that's division property of equality. What's the other one? Right. If you had the problem 8x equals 32, what's the very first thing you would do on both sides? You would divide by 8. That's why it's called the division property of equality. And you're doing it on both sides, which is why it's a property of equality, because you're keeping both sides equal by doing the same thing to both sides. And so when you do that, x would equal 4. Are y'all starting to kind of get it? I can't really see that far, but it looks like it, though. Okay. Substitution property of equality says if A equals B, then you replace B with A in any expression. So it's just saying if two things are equal, you can substitute them for each other. So one of these is if 3x plus y equals 8, and somebody tells you that y equals 2, couldn't, instead of you writing 3x plus y, you could just write 3x plus 2 equals 8? Because if y equals 2, can't you substitute 2 in the place of y? Right. Correct. If you have a problem like 5z plus 3x equals 12, but somebody tells you that z equals 2, then you can just rewrite it as 5 times 2 plus 3x equals 12, or you can even simplify that and just write it as like 10 plus 3x equals 12, right? You're just substituting something in for a variable when you know what the variable equals. And then obviously you only have 2 remaining, and what do you notice about both of those? Okay, and what's going on in both of them? What property? Distributive property. That 3 times y minus 2 becomes 3y minus 6 because you distribute the 3 to both things. And then the 2 times y plus 2 becomes 2y plus 4 because you distribute the 2 to both things. So glue those down in the last one. And now we're going to practice some of these in your packet. So once you get finished gluing, turn in your packet to page 5. Okay, turn in your packet to page 5. Look back. Okay, so everybody pay attention. By now you should have out your packet. Turn to page 5. All right, number 1 says, if you add the same number to both sides of an equation, the equation is still true. For example, if A equals B, then A plus C equals B plus C. So all you've done was added C to both sides. What property is that? Right. Kind of common sense, right? You're adding the same thing to both sides, so it's the addition. And then for property of equality, we can just write POE. Addition, property of equality. So I know you feel a little overwhelmed by all these properties, but when it comes down to it, aren't some of them really common sense? Yes, look, you're adding the same thing to both sides. So that is addition, property of equality, because you're adding it to both sides. Number 2, if you multiply the same number to both sides, the equation is still true. For example, if A equals B, and then you multiply A by C and B by C, they're still equal. So right, they're multiplying by the same thing on both sides. So that is the multiplication property of equality, because they just multiply by the same thing on both sides. You're keeping it balanced. Okay, that's what it means, property of equality. The equation is staying balanced on both sides because you're doing the same thing to both sides. All right, number 3, one that's not as obvious. What property is illustrated by this statement? If A equals B and B equals C, then A equals C. Right, that is the transitive property of equality. Okay, if two things are equal, or if two things equal the same thing, then they equal each other, is what the transitive property of equality says. If A equals B and so does C, then obviously A and C are also equal, because they both equaled B. That is the transitive property of equality. All right, number 4. If you subtract the same number from both sides of an equation, the equation is still true. For example, if A equals B, then A minus C equals B minus C. Correct. You're subtracting the same thing on both sides, so that's the subtraction property of equality. That one's a common sense one. Number 5? Almost. What property is represented by the following statement? If A equals B, then B equals A. Which one did I say? No, the transitive was up here. Symmetric property of equality is when you just flip-flop the sides. Remember, reflexive is when they're the same on both sides, like identical. These are flip-flop. If A equals B, then B equals A. That's symmetric. All right, number 6. If you divide the same number to both sides of an equation, the equation is still true. For example, if A equals B, then A divided by C equals B divided by C. Well, what are they doing to both sides? Dividing. So it's the division property of equality. That's another common sense one. The adding, subtracting, multiplying, and dividing ones are simple. You just look at what they're doing on both sides. Okay, number 7. If you divide the same number to both sides of an equation, the equation is still true. For example, if A equals B, then A divided by C equals B divided by C. It's also division. I don't know why they did that. I'm just going to draw arrows. I think that's an error on their part. I know. I don't think they meant to do that. Oh, did it? Like back to back like that? Oh, at least they were separated. Yeah, if they're going to repeat it, they need to separate it a little. All right, number 8. The equal sign is like a mirror, and the image it reflects is the same as the original. If A equals A, anything is congruent to itself. Reflexive, right. And they even give you good hints in that one, like a mirror reflects. That's the reflexive property of equality when both sides are identical. All right, number 9. If you multiply the same number to both sides of an equation, the equation is still true. For example, if A equals B, then A times C equals B times C. What? Right, that's the multiplication property of equality because they're multiplying by the same thing on both sides. Hold on, I'm letting people catch up on writing. What? I literally just now got it 2 seconds ago. Must start. You got to catch up, so you must start. You mayonnaise. Trying to think of something else. You mayonnaise. Okay, number 10. What property is illustrated by this statement? If A equals B and B equals C, then A equals C. Right, that's transitive. When two things equal the same thing, then they also equal each other. Transitive property of equality. Number 11, if you subtract the same number from both sides of an equation, the equation is still true. For example, if A equals B, then A minus C equals B minus C. Right, subtraction property of equality. You're just subtracting by the same thing on both sides. Well, especially the adding, subtracting, multiplying, dividing. They're common sense. All right, what property is represented by the following statement? If A equals B, then B equals A. That is symmetric. Remember, reflexive is like a reflection in the mirror. They're the same on both sides. Symmetric is when you just flip-flop the sides. And then the next is the same exact thing, so just draw arrows. Number 12 and 13 are identical, so just draw an arrow. Number 14, if you divide the same number to both sides of an equation, the equation is still true. For example, if A equals B, A divided by C equals B divided by C. Right, the division property of equality. All right, and then number 15, if you add the same number to both sides of the equation is still true. For example, if A equals B, A plus C equals B plus C. Addition property of equality. Okay, now turn to page 6. Okay, listen, we have 7 minutes left, so you're going to start on this now. But whatever is not finished in the next 7 minutes will turn into your homework. Page 6 and 7, they're multiple choice. There's only 12 of them. Guys, I have told you what these properties mean, but it's now up to you to memorize it. So copying somebody at this point is not going to help you for this test. You need to literally look at number 1, see if you can figure it out on your own. If you can't, look at your little flip book and see if you can figure it out. This is where you actually learn them yourself so that you'll know them on the test. So get busy.